So today we're going to look at the properties of covalent compounds. And first I want to compare them to the properties you might find in ionic compounds. So let's have a look at the states of ionic compounds. They exist as solids. Ionic compounds exist as solids at room temperature, whereas covalent compounds sometimes exist as gases or liquids, but they certainly do sometimes exist as solids. So the states tend to be often more of liquids and gases as well as solids. Now, there is a misconception I do see sometimes that all covalent compounds are gases, and all ionic compounds are solids. I want to. It's not what defines a covalent compound versus an ionic compound, so please don't believe that. Um, this is about the states that they exist in, because covalent compounds definitely can be solids after all, like candle wax is a solid. You can have a variety of solids. Wood is a covalent compound. Plastics are covalent compounds. These are all solids. Okay, so melting points tend to be high. Covalent compounds tend to be low. Low melting boiling point. Ionic compounds tend to be able to conduct electricity. Covalent compounds generally cannot. There's one exception, maybe, which, if you know it, put it in the comments below for some extra points. Soluble in water, but it tends to be insoluble. Insoluble in organic solvents, and sometimes soluble. I mean, that's a bit dependent, but anyway. So what's going on here? What's really going on? So it tends to have low boiling point, and tends to be more of a liquid and a gas rather than a solid. So think about this. What we're really talking about here is the intermolecular forces, the forces that are between the molecules, right? If you're going to boil something, if you're going to turn it into a gas, the strength that these two molecules hold on to each other is going to determine how easy that's going to be, right? If you imagine you and all your friends are holding hands or gripping onto each other's shirts, and I try to turn you into a gas, I try to break you all apart and spread you through the room, the tightness, the strength of your grip is going to determine how much energy I'm going to need to do that, right? Whereas if you have a very tight grip, you're not going to move into a kind of gaseous random form very easily. If you are a very weak grip, then you can fly apart more easily. So that's suggesting that, or these two are suggesting that somehow those intermolecular forces, the bonds between the molecules, are weaker in ionic compounds versus covalent. So let's see if we can justify that. When we're talking about an ionic compound, that we have cations, right? So a molecule that's lost an electron and now has a positive charge, being really attracted to a negative anion, an atom that's taken on an electron and become an anion, right? So there's a direct kind of positive-negative electrostatic attraction, isn't there? These are held together by a very strong electrostatic attraction. When we're talking about covalent compounds, on the other hand, they're electrically neutral. All right, they don't have an extra electron or haven't lost an electron. Remember, they're sharing an electron. All right, so there's no no massive, positive and negative ions in covalent compounds. What we sometimes have is an uneven distribution, right? When this molecule up here, the red oxygen in the water, is more electronegative. Remember, electronegativity means that it attracts those electrons more strongly. So there's more electrons hanging around up here, right? And less down here. But this might be a bit more negative. This might be a bit more positive. This is called polarity. I think I might have mentioned that in a previous video. Well, in that case, there'll be a little bit of attraction here between this negative end and that positive end, right? but it's not, and it is actually relatively strong compared to other covalent compounds, but it's nowhere near as strong as you might find in an ionic compound, right? Where the whole molecule is negative and that whole molecule is positive. And this one's slightly negative and this one's slightly positive, so there's some kind of attraction there. So you can see that that's weaker. But generally, what we see in covalent compounds is this kind of situation where there's no negative end, no positive end, or rather that the negative end is only negative because randomly every now and then electrons are going to be more over this side or over that side, which creates a momentary negative end and a momentary positive end, and then they'll have those moments of being attracted to each other. But on the whole, there's not this big electrostatic attraction. So why is a covalent compound weaker than, or covalent bond weaker than an ionic bond? Well, because an ionic bond has these, big positive cations and big negative anions, whereas a covalent compound doesn't, right? They're all electrically neutral. Within the molecule, there might be a little bit of a negative end, a little bit of a positive end, either through electronegativity or just random chance that'll have some kind of interaction. But overall, that means that they're weaker bonds, which means that it's going to make it easier to boil, and therefore we might have more kind of gaseous and liquid states rather than ionic compounds, which are almost universally solids. So that's it for today. Answer the question below, and I'll see you in class.